Hello friends and welcome back to my channel. Today our objective is to see what are joins in PostgreSQL server. Okay. So as usual, the agenda would be brief understanding of the joins in PostgreSQL server and then a practical demo. Okay. So let us, first understand what are the joins. So basically joins are nothing but, in the relational database management system, whenever you want to get the data from two different tables, that is one or more different tables, then you will always have to join those tables on a common key or a common column, right, which identifies the as a joining, which is identified as a joining condition, and that from that's where you will get two the data from two different columns from two different tables. So join is simply nothing but joining the tables on a common column or a common key value having in both the tables. Okay. Now there are, today we are going to see this type of joins. Like there are different types of joins like inner join, outer join. Outer joins are again categorized as left join, right join, and full outer join, and then a self join, cross join, and a natural join. Basically, these are very basic types of joins which you will find in almost all the RDBMS products. Okay. So let's action. So before we action, let us individually first understand through the Venn diagram that what are joins. Okay. So as I told you, we are going to see different joins. So let us start with the inner join. So here you can see, I have two tables. Okay, employee table which contains employee ID, employee name, and department name, and a department table which contains department ID and department name. So here my department ID you can see is a common column basically between the two tables, or you can say a joining column between the two tables. Okay, so what is in inner join? So in an inner join, right, it fetches only as a from a Venn diagram it fetches only the matching record from both the tables. Okay, so when we say that we are we want to join this on a department ID, so department ID present in both the tables, the common department ID present in both the tables, only those rows from both the tables would be fetched, and there would be a unique rows would be fetched. Okay, so from Venn diagram it is very easy to understand that only the matching rows from both the tables would be displayed. Then let us come to an outer join. Outer join, as I told you, contains three joins. One is left join, one is right join, and third one is full outer join. So what is in left join? Okay, what is left join? So basically, when we say left join, actually it will retrieve all the rows from the left hand side of the table and only matching rows or the data on a match in a column for the matching rows from the right hand side of the table, and for the rows wherever the the joining condition is being not matched, for the left hand side of the table for that column the null would be displayed. Okay, so here for example you can see on a this sorry. So you can see here on a data that employee ID 1, 2, 3, 4, 5, 6. Now for employee ID 6 we don't have any department ID, and my department name is fetched from my department table. So for that's where it is showing as a null, because in my employee table for employee 6 no department ID is being actually entered. Okay, so very simply in left join, all the rows from the left hand side of the table, and not we cannot say matching rows, the data from the matching rows for that column would be displayed, and for rest of the rows where the data data that is the joining condition is being not matched, it will be displaying null. Right join, it is very altogether an opposite of the left join. So basically all the rows from the right hand side of the table and the data in the matching columns or the data with the matching rows would be displayed, and for the rest of the rows you will be displayed as a null. Okay, so here you can see my department 5 is not contained in employee table, right? So for my all the employee rows for department 5, my employee records are being displayed as null. Now, when I say left hand join and right join, right? Now it does not depend on the joining condition, which you can see as an highlighted, right? It makes no difference if you write dep.dptid is equal to emp.dptid or emp.dptid is equal to depd. It doesn't make any difference. The difference make with an the left join or the join clause, right? So when I say left join here, right, whatever table is specified on the left hand side of this clause is considered as the left hand side table, and the table on the right hand side is considered as the right hand side table. Okay. Let us move on full join. Full join is the combination of a left and a right join. Okay, all the rows from employee, all the rows from department, and wherever the joining condition is not being fulfilled, a null value would be shown respectively for that column. So here in left join, you saw that department for employee 6 department was null, and for right join for department 5 employee records were null. So similarly, you can see here all the records would be displayed, but for employee record 6 it is this is null, and for department 5 employee records are null. Okay, and then comes a cross join. Cross join is nothing but a Cartesian product. In cross join is the only join where you don't specify the joining condition. In this case, everywhere you need to specify the joining condition. You can see this is called as a joining condition. Okay, on EMP DPT ID is equal to DPT ID. Everywhere you can see the joining condition is there, but sorry, cross join is the join where you don't specify the joining condition, only you say cross join between the two tables. In this case, each row from left hand side table would be joined with each row on the department, the right hand side of the table. So for example, my employee contains 6 rows and my department contains 5 rows, then total 30 rows would be displayed, right? Or the results would be retrieved. Total 30 rows would be retrieved because we don't have joining condition, and each row from the left hand side table would be mapped with each row from the right hand side of the table. Okay. So this was basically a theoretical part. I know you get bored with the theory. So let us see something in action here. Let me create an environment first. I'm using again the same DVD rental database here. Okay, I'm dropping the tables and I'm creating, taking the same example which I had shown you into the theory. So I have created two tables. One is employee and one is department. And employee contains employee ID, employee name, and DPT ID, and department contains DPT ID and DPT name. So you can see here DPT ID is a common column on which we can join the two tables. Okay, let me insert the records first here in both the tables, right? So records are actually inserted. Now you can see there are 5 departments: department 1, department 2, department 3, department 4, and department 5, and there are 6 employee records. But here, as I told you, in my employee record, you can see employee 6 doesn't contain any department ID, which is a null value. And department ID, as I told you, that there are 5 records, but here you can see the number or the department ID used are only 1, 2, 3, and 4. So basically, we have skipped the department ID 5. Okay, so let us start with inner join. The basic syntax would be select, then you can specify the column names, then from, and then you can say employee, this is my right hand side table, this is an alias, and then inner join, this is the clause which is must if you want to have an inner join, then a department table, that is this is the right hand side table, and then a joining condition. With the help of on clause you can specify the joining condition. So we are writing here, or we are specifying, please join employee and department table on DPT ID. Okay, so let us see, execute this. And you can see here employee record 6 is actually uh, eliminated, okay, omitted, because it doesn't contain any department, right? And in an inner join we saw that only matching rows would be fetched. So you can see here employee 6 is actually eliminated. Now, with PostgreSQL Server, you can use, right, instead of actually putting this all together on and then a joining condition, if you have the common column name between the two tables, then you can use this syntax, uh, that is using DPT ID. So rest of the query remains the same. Only instead of the joining condition on, you can say using DPT ID, which identifies that DPT ID is a common column between two tables and can be used as a joining condition. Okay, so if you execute this query, you will get the similar results. Okay, guys. So this was an inner join. Let us move to the left join now. Again, query remains until here, query remains the same. Sorry, this is left join. Until here, query remains the same. Then here you specified inner join. Now we are specifying left join. Department again the same department ID because this is the only column which is common between the two tables. And as I told you, it will not make any difference if I reverse this position of this columns. Okay, right? W- The left hand join depends on what? As the as I told you on this clause. So whatever table is specified on the left hand side of this clause would be a left hand side table, and on the right hand side of this clause is an right hand side table. So let us see what results we get back from here. So as I shown you in the theory, you can see employee, 1, 2, 3, 4, department 1, department 2, department 3, department 4. Now here employee 6 is also retrieved, but for department name, because it doesn't contain any department ID, the value is shown as an null. Okay. Similar for the right join. Okay, it's a vice versa. So if I execute this, you can see all the records from right hand side table. That is, there are five records: department 1, department 2, department 3, department 4, and department 5. But department 5 is not at all, specified in my employee table. So for the matching for those columns from the employee table, it is shown as a null value here. For department 5, it is null value because department 5 is not, never used in my employee table. Okay, so this were inner join and outer join, that is left, right, and full join. Now let us see cross join. So as I told you, we just specify the cross join clause and we don't specify any condition. So when I execute here this, you can see like 30 rows are basically retrieved. And as I told you, each record from an table is mapped with each record from a right on a another table. So you can see employee 1, 2, 3, 4, 5, and 6 record. We have an employee table. So it is mapping to department 1. Then again employee 1, 2, 3, 4, 5, 6 to department 2. Employee 1, 2, 3, 4, 5, 6 to department 3, and so on. Okay. So this is nothing but a cross join. Okay. Right. And I think I just forgot to show you full join. So with a full join also, if it's only the difference of how what clause you mentioned. So here we are saying full join, and when we execute this, you can see for department 5, employee records are null, and for employee 6, department record is null. So as I told you, the record from both the tables would be fetched, but depending upon the joining condition or the joining column, for the matching records, the value from that table would be shown. If it doesn't match, then null value would be shown. So this was full join. Then this was a cross join, as I told you, mapping of each record with another record, right? Cartesian product. So you can see here total 30 rows are being displayed. And there is one more join called as a natural join. Okay. Now, in PostgreSQL server, it automatically identifies, the common column between the two tables and it joins the table. So this is as good as inner join, or it may be a left join, right join, but this is as good as inner join, and you don't specify the condition here like a cross join. But in cross join, it will create a Cartesian product. Here it will basically use as a natural, with the help of natural join, it will use as an inner join, because with the help of natural join, it identifies the joining column, the common column between the two tables, and then join on that column. So when I execute this, you can see again, like the records are, or the result is displayed as per the inner join only. Employee 6 has been omitted. So this is a natural join where that uh, there is a common column between the two tables. Then you can actually omit the on clause or the using clause to specify the joining column, right? So this was basically, guys, the inner join, the outer join, cross join, full join, natural join. Okay, now one join is remaining, that is self join. Okay, let me clean up the environment and let me create the table again. Now I'm creating a table here, and let me insert the records into this, and then I will tell you what is the purpose of self join. Okay, now here you can see I have created an employee table again, and with the employee ID, now I have a manager ID. So basically, the purpose of general purpose of self join is if you want to find an hierarchy, right? So if you want to find from a table, if you have a table like this, that each employee ID, contains the manager ID also. So if you want to display the name of a manager, right? For example, who is the manager of Mark? Who is the manager of Muller? Who is the manager of Rakesh, and so on, right? In that case, you can use a self join. Self of join is nothing but you are joining the table within itself. Okay, so you are joining employee table with employee join itself. Now it can be a inner join, left join, or right join. It doesn't matter. Depending upon the business requirement, you can use inner, left, or a right join. Okay, but basic purpose of self join is to find an hierarchy rows. Okay, so here you can see for John, I don't have any manager ID, so maybe he is the CEO of the company, right? For Mark, manager ID is one. So basically, John is a manager ID for Mark and Muller. Similarly, for Rakesh, Mark is a manager ID, and for Kirit also, Mark is a manager ID. For Hitesh, Muller is a manager ID, and for Nikhil, you can say Hitesh as a manager. Okay. So when we execute this query as a self join, you can see for John, right, it is coming as null because for zero, as we have joined in left join, and for, now the characteristics of the left join, right? If no matching value or the data is found on a joining condition, it actually retrieves null value. Okay, so for John, we know for zero there was no manager ID. So for Mark, John, Muller, John, for Rakesh, Mark, Kirit, Mark, Hitesh, Muller, and Nikhil. For Nikhil, Hitesh, and so on. So this way you can find out, who is the manager of whose employee. Okay, so this is a self join. Very important, many times we forget the purpose of the self join, but this is one of the purpose. Now again, self join is not limited to this, but this is one of the major purpose of finding the hierarchy. Okay, so this was a self join. So yeah, that's it for today, guys. This was hope you understood about the joins, the basic concepts of joins, and the types of joins in Postgres SQL Server. As usual, do as much as practice you can do with different types of joins. Okay, because if you are going into the development area, then you will have to write a joins or the complex query day in and day out. So understanding the basics of joins is very very important. Okay. If you have liked the video, please, don't forget to press the like button, subscribe to the channel, so that you will keep getting notification whenever I upload such videos on Postgres SQL Server or Microsoft SQL Server. Okay, so thanks guys for watching this video. Bye for now. Meet you in the next session with next topic. Till then, bye and take care.